So hello everyone, welcome. I am John Whitmer. I'm the Director for Analytics and Research with Blackboard, and it's my pleasure to present today this paper about X-ray learning analytics. So one of the questions that we've been facing as a community is how to scale up the innovations and the exciting stuff that we do in research, the findings that we have, what we come up with, and what we see often from a single course or small samples and sets of courses to things that are able to serve and fulfill the mission of learning analytics at large scale. And so today's paper is an example of that. Blackboard bought Xray, which was a research-based project last year, about the middle of last year in June. It was acquired and integrated into the Blackboard family of suites. I serve as a product manager of that, and Sasha Dietrichson is the founder and chief data scientist now with Xray. So he's going to speak about some of the challenges at multiple levels that we've faced and solved, we hope, in integrating and taking this research-based application to scale. Thanks. Sasha.
Thank you. So we should probably mention Vera, Friedrichs, and Diego Forteza, who were also part of this team effort to move this application from a research-based application into an enterprise level 1. So just a little background. What Xray does, and I'm not going to talk too much about it, is it analyzes LMS data. It pulls data out from Moodle, or any other LMS for that matter, moves it to a separate data store, and we run a bunch of reports and stuff on it in that separate data store. And it was acquired, as John mentioned, in 2015, so last year. And what we had to do at that point was to integrate Xray into Moodle rooms. I know there's another project going on now to integrate some of it into Blackboard Learn as well, but Moodle rooms was the first order of business, and we had to make it end-user friendlier, we were told by people who looked at it, and then probably the most important part of it, we needed to be able to scale it to deliver to 2,000 or 3,000 clients at the same time, and then build a support structure for it as well. So our previous biggest challenge had been to support 3 clients simultaneously, and it was on a semester basis. And the truth of the matter is we had quite similar courses because these were people who chose to collaborate with Xray more on the research side than the commercial side. So there was a certain element of self-selection bias there, and we quickly discovered that once we started digging into the vast data sets that we had available at Blackboard. The other thing, and we were able to scope this or limit the scope on this, is that we needed to be able to support deployment in a lot of different countries, and that has to do both with language, because a lot of Xray is linguistic analysis, and it has also to a certain degree to do with legislation and privacy laws that differ in different regions of the world, and we had to make sure that we were good for all of that. So this is the not so user-friendly way that we accessed Xray up until very recently. There was a separate login. We could put a link inside Moodle, and then we might be able to skip over this login screen. After the login, you got to a dashboard where you could click into different parts of the application, and it was essentially separate from the LMS. The new version, the integrated version, essentially looks like this, and what you see here is a sociology course, Sociology 101, that's a demo course, where we've placed some of the elements from the analysis directly on the course homepage. This is the first thing the instructor sees when he or she logs in. And the idea here is we actually want it to be intrusive. We want we actually want to force the instructors to take a look at this. If you click on any of these links, you go into the individual reports that have more meat, but this is sort of this, we call this the headline data section. So if Xray is enabled for a Moodle Rooms domain, then this will show up. And you click on one of these, and this is an example of the activity report. So we did a lot of design on this. We had to do, we redesigned some of the visualizations and threw a lot of them out because one of the results from the studies that we had been doing was that it was overkill for a regular instructor. We spent a lot of time looking at this and thought they were gorgeous, but there were 80 visualizations and they refresh every day. We figured the instructor is not going to have time to look through this, so we selected, I think came down to 30 altogether, between 4 or 5 different reports. And this was tough for for those of us who had spent a lot of time creating all of this, but it's necessary to be able to scale it out. And the integration strategies we used, and this is where it becomes more general for any kind of research application. We chose to use JSON for data transfer. So we store all the reports as JSON structures in a database. It doesn't really matter what database it is. Well, we happen to use Postgres, but Oracle has it, and pretty much all the databases will work with JSON natively these days. And that means that it can be read from any other programming language. So there's a front end, which is written in PHP. The actual analysis part of it is written in R, programming language for statistics. And then there's a middleware that produces the web services. That's actually written in Node.js. And these all talk together because it's JSON and because we're using web services. And that means that each individual element of each report has its own URL. And the front-end people in the plugin essentially just hook it up. They calculate the URL and then they hook it up and display it. And that makes it very flexible as well. And then there was some standards compliance that we needed to tackle. Some of it was legal, and that had more to do with privacy laws. And the only way you can sort of get around that, or what we found that we needed to do is, for example, if we are going to deliver Xray in Germany, we have to deliver it in a data center in Germany because the data cannot leave the country. The same is true for Australia. But since we use Amazon Web Services, since it's cloud-based, we have scripts that will spin that up in an hour or so. It's very, very efficient. So that part of it was not, the technical part of that was not too much of a challenge. Accessibility was a bigger challenge. Some of it has to do with navigation, and accessibility in America often means 508 compliance. There are similar norms in Europe with different names, but some of it has to do with navigation. You're supposed to be able to navigate through an application. Some of it has to do with contrast and palettes you use for the colors. For colorblind users. And then for the non-sighted users, you need to present everything in a tabular format. So the navigation stuff we didn't touch because we didn't design the front end, so it really wasn't our problem. But we are producing all the visualizations. So we needed some more contrast, and I don't know if you can actually see it on this screen. But this is a before and after. We had chosen colors at random, the data scientists that we liked, and then the designers who know what they're doing when it comes to accessibility, they made some changes to the colors. And it's, this isn't actually rocket science. There are tables available online if you don't have an accessibility department in-house. that you can use. And this was a particularly unfortunate case on the left here. I believe there was a typo in the source code, so it defaulted to black. And the redesign, of course, is not only more accessible, but a lot nicer to look at. And then we came to the tabular versions of the visualizations. And this is technically trivial because we have tabular versions going into the visualizations when we make them. But it sort of goes down, goes back to why we visualize at all. This is a bunch of numbers. This is the tabular version of those numbers. And this is the visualization of those numbers. And we weren't sure if we were helping anyone by producing a tabular version of this visualization, essentially reverse engineering it. We don't have to reverse engineer a lot. We have the tabular version. But are we helping a non-sighted user? Here's another example with only 10 data points. And if you're good at eyeballing data, you can see that the lines cross at the end. This is only 10 data points, and it's still not obvious that you can extract the same information from the tabular data. So we divided everything into 3 categories. There's low density. Here we actually have 14 data points. There's 1 data point per day and 1 data point per day last week. So this is relatively easy to put into a tabular format, and it's reasonable that you should be able to extract the same information with a screen reader. And here we have one that has a little more density. There's 120 data points. This is 4 months of activity data. Then we have a smoothed average, and then we have a confidence level. So now we have 480 data points. And we can still spit this out as a table, but now it's getting more, it's iffier if it's actually useful. And then we have this very high density. So this is a density plot, and we're essentially, from high school math, you will have done derivation and integration. So you know that in principle, there's an infinite number of data points on this curve. And this obviously we can't spit out in a table, nor would it be useful at all. In practice, the number of data points given is a function of the resolution on your screen. But mathematically, this is an infinite number of data points. And so we said, why don't we just ask the users? And we couldn't find one. We could not find a non-sighted teacher that used Moodle. And we're the biggest e-learning company in the world. So we sort of had to try to follow the guidelines, knowing that they were not really written for this specific purpose. They weren't written with this in mind. And maybe if we engage more with the community, we'll get some better guidelines. And then along came the infamous dash, because we had a discussion about how to best represent missing data. And the problem, first we had the problem with, let's say, the sighted users who did not like NA, which is what data scientists would use for missing data and have no problem with. So we replaced it with a dash. Not to leave it empty because it looked so empty when it was empty. However, the dash, if you run it through a screen reader, maybe it's read like a minus sign, and we still didn't have anyone to ask. And this is when John said that we will wait for the actual use case before we decide on what is the best way of doing this. And we essentially decided to postpone that whole decision until we had a real case. So the approach here is, low density gives high fidelity. If you have 14 data points, you can spit them out. If you have 100 or 200, you actually have to sample those data points to make it even reasonable. And of course, if it's infinite, you're stuck, and you do the same thing. You do a little bit of sampling. And it is likely that we need heavy-duty artificial intelligence to actually solve this problem, where you would have an artificial intelligence who could explain what each visualization looks like, because that is a matter of interpretation, and we're not there yet. And then there were methodological challenges. As I said earlier, there had been some self-selection bias, so we needed to be able to create new models, not just for each institution, but it meant in many cases several different models within the institution. And for that, and then we serialized the models. And I can tell you briefly how that is done. We generate a model in R, and then we store it in the database. And then when we need it, we pull it back from the database. That way, we don't actually store any trained models in source code or on disk. And that, first of all, it gives you a flexibility to do this and stay organized, keep track of everything. And secondly, it gives us a database of models that we can use for the cases when a client comes on board that does not have any historical data. Because the procedure that we follow is we will mine the historical data for patterns, and then we implement those in the models for each individual institution. Now let me see, I can show you the, this isn't going to look good, is it? Let me see if I can change the resolution here. I wanted to show you the onboarding app that we use, but it is built for my computer screen, so it's not going to look ideal here. But I'm going to sort of see if I can do this. So now I've connected to a domain. We have dumped all the data that was available on the client side into our database, our being the data scientists. It doesn't move much, it's all in the same data center, but you don't want, if you have a production instance of an LMS running, you don't necessarily want data scientists to be running simulations on that same data. So we make a copy of it, and move it to a different database. And in this case, we actually use Postgres, and Moodle is usually MySQL, I believe. Sometimes it's Oracle. So we have our own stuff to play with. And then we do some filtering, because I'm going to use this to train my models. What we found is, and this is a typical example, you have courses that have 2,000 students in them. And they're not real courses. They're a course that everyone automatically gets enrolled in, but there's no real activity there. So what we do here, this allows me to filter and say, for my training, I want a subset of this, and courses that have only one student aren't really interesting, so I'm going to put that at 9. And then I can look down here on some relationships, and I can filter out, relatively quickly the courses that are not reasonable to use to train a model. For example, I don't want courses without an activity log, because I need that for the training. So, I can do that. And we do, and then you can cluster. I'm going to see if I can do this. I can run the simulation and see if there are any clusters here. I just chose access and used k-means because it's the fastest one. And you can see that it converges at 4. So there are, if you look at this, you can say there are clusters here. There are 4 of them. We don't really know what they are, but we can cluster it that way, and then we can ask the client, what do these clusters represent? And then we can use that in our modeling. There's 2 ways, essentially, we can do that. We can either use that as a variable in any model we want to create, or we can create, in this case, 4 different models, and just say if the course is of type A, we use this model. If the course is of type B, we use this other model, or combination thereof. So this lets us start with some of the modeling, and the idea here is that we do this in collaboration with someone at the institution, because we're going to get a list here of courses that we can also visualize this. So I want it 4, and I want it as a fan. We can look at the clusters, and we see here that there isn't really 4 clusters. The smallest clusters are so small that we should probably just ignore them. The green ones, there are course numbers on the outside here. The green ones completely dominate, and the smaller ones, so it's probably not worth using this in this particular case. But this is the kind of stuff that we do again in collaboration with the client. If I wanted to use these clusters, I would just click here, and this information would be put back into our database with those course numbers. And then we do something similar with the course participants. We call them participants. They're students and instructors, both of their, and anyone who accesses is actually in there. And so one of the things that we do here is look at, are there duplicated accounts? Because we want to know that when we do the modeling. And then similarly, we can filter like we did for the courses. The student that's enrolled in 100 courses is an admin or some kind of, it's not a real student. So I'm going to pull this down to, let's say, 20. And minimum 8 students. So now I have selected a list of courses, a list of students, and I can continue doing this and filter out all the noise in the data, so that I can hopefully successfully train a model to be used in the implementation. And we can do clustering and stuff here as well, but I see that I'm actually running out of time. So here we go. And this just, this is analysis of all the grades. And essentially what I'm doing is I'm superimposing a density plot of the grades by course on a density plot of the grades by student. And if they're different, that means that there is some bias there. So that's something to take into account when you model. It means that some courses are easier than others, or that there's a clustering of students. If not, they would coincide. In this case, actually, the conclusion is that there is no bias because we've filtered out so many students and courses that we don't have a p-value anymore. Anyway, I'm going to go back to the last 2 slides here. The infrastructure challenges that we had to do with porting everything to the cloud. And it says drone-based architecture. We used to run everything we did on huge machines, the biggest machines we could get our hands on, with 32 cores, and we ran stuff in parallel. It turns out if you want to do it at scale, that doesn't really work, because one of the cores is going to crash, and you don't know which one it is, and you have to track it down, and it becomes a nightmare. So we went the other way. Now we're using the absolutely smallest machines, but we create 200 of them, and they start working. And if one crashes, we know which one it is, and we can freeze it, and it doesn't affect the rest of the workflow, and we can go in and diagnose. I believe these are essentially pretty standard practices in cloud computing. And then we needed to automate testing and deployment and source code management, also using best practices from, this is rather computer science than data science or learning analytics, but that is where you get if you need to scale up, like we've had to do with Xray. So I'm going to leave this last one up and take questions in the interest of time.
Perfect timing.
Yeah.
Questions from full room here. Ellen.
So in the QA platform, there's lots of accessibility tools. So what am I missing? Why can't you just use an accessibility tool? You spend 5 minutes talking about the difficulties of accessibility, but there's just accessibility checkers out there that you just throw your reports at. So I was wondering, what am I missing?
So the problem with the accessibility in our case was you have to provide accessible versions of the graphics, which means you have to provide the underlying data in a tabular format. But when that underlying data is, has 2,000 data points in it, I mean, you can still do it, but it didn't seem natural. It didn't seem like we were making anything more accessible by just doing a huge data dump. And that's why we got into that.
It's a little, this is Dan, I'm also from Blackboard. It's a little bit more than just describing it with some descriptive text. Because if you're using that to see if it's close to a sine curve, or you're using a defined outlier, you need those data points in some format that somebody can consume. And just the accessibility industry is not there with these graphical tools. There has been some work done in the IMS context to say it's an SVG, and so we could annotate the XML that actually renders the SVG in some way, but there's no standard for that yet. And that's when we end up in these edge cases where there's an infinite number of data points, and so that table is just as unuseful for that user.
Because it's about meaning. It's about interpreting the meaning of the visualizations, not whether they could be rendered or not, right? Come up with an alternate text for that, and it's not useful. So it's really about having something, so we can't do it ourselves to provide interpretation tools for sighted users, right? Let alone to have a meta checker on that. Those don't exist. The whole accessibility frontier in visualizations is a very big, data visualizations is emerging, but it's still very young. And so we just ran up against it.
Any more questions? Impressions? Yeah.
Maybe just to follow up on the point. If the talk is about going enterprise, is that the point of the accessibility? Is if you were to take this and scale it to larger instances, this is an issue that you have to address? Is that the main point with the accessibility?
Yes.
Yeah, and it's one I don't see us talking about much at LAK, right? We do visualizations and such, but there's not a lot of conversation about it. So how do you make, there's all this work on making effective visualizations, but what if the point is that someone can't see it? Right? So then what do you do in that case? How do you address that? We're still figuring out what good visualizations are for sighted users, right? That's our main challenge. And this is the case that Sasha, and we did, in all honesty, we did have jokes around, so how do you, make invisible, non-existent data for a non-sighted user that, doesn't exist? Like, those are things you actually have to address. Like, you have to do that because it's legally mandatory, right? In protection of protected classes. So, it's something, that's the point is that it's something that, we haven't really thought about very much, I don't think, as a field and an industry solutions. And this is the approach we took to come up with the best solution we could.
Here, right down the back, Adam. That's very interesting. This middle point of heterogeneity of real-world necessitates strategy management. And this is something which is on my mind quite at present, is how you can understand what differences in activity mean in relation to a pedagogic and not pedagogic in a wide setting, the online pedagogic structure in which those activities are taking place. I thought you were going to talk about that. I didn't hear a great deal. I'm sure you've got some interesting comments to make about how you can essentially recalibrate different intentions, different thought areas and
Yeah, so my solution was to filter most of it out, and then cluster what was left and separate it out so that you can have several different models for different groups of courses. And in principle, you could do this for an individual course. You could do it for an individual user, for that matter, but that is probably not scalable. So you come to a point where if you need that level of specificity, you are going to spend more resources than you are willing to spend. So you have to sort of make a trade-off. It was not satisfactory to us to say, well, first of all, we were clear that it's not like one size fits all. We need specific models for specific cases. And it was also not satisfactory to say, an institution will use this model that we trained for them at the beginning of the semester because we saw these patterns that went, it makes perfect sense. They're different, division schools, teaching styles, but going all the way to a individual course level, we just don't have the resources for it. Nor is it clear that that will be tremendously useful because you lose generalization. Yeah.
You're fine. You can keep talking.
Thank you.